Welcome to our channel, Mind Mentor. In this video we will understand the concepts of Gibbs Free Energy, its relationship to spontaneity, and how it relates to equilibrium. Gibbs Free Energy, G, Gibbs Free Energy, G, is a thermodynamic potential that combines information about a system's internal energy, U, temperature, T, and entropy, S. It is a critical concept in thermodynamics, particularly in the study of chemical reactions and phase changes. Relation to spontaneity, the Gibbs free energy, delta G, is closely tied to the spontaneity of a process. Spontaneity refers to whether a process occurs on its own without external influence or intervention. The relationship between delta G and spontaneity can be understood through the following principles. Delta G and spontaneity. 1. If delta G less than 0, the process is spontaneous under the given conditions. This means that the process will naturally and energetically favorably proceed in the forward direction without the need for any external intervention. The system tends to move to a state of lower Gibbs free energy, which corresponds to a more stable state. 2. If delta G greater than 0, the process is non-spontaneous under the given conditions. In this case, the process will not occur on its own, and an external input of energy or work is required to drive the process against its natural tendency. 3. If delta G equals 0, the system is at equilibrium. At equilibrium, there is no net change occurring within the system. The forward and reverse processes are occurring at the same rate, and the system has reached a state of dynamic balance. The Gibbs free energy is at its minimum possible value under the given conditions. Equilibrium, delta G equals 0, 1. Delta G less than 0.1. When delta G is exactly 0, delta G equals 0, it indicates that the system is at thermodynamic equilibrium. 2. Equilibrium is a special state where there is no driving force for change. The system is in a stable, unchanging condition. 3. At equilibrium, the forward and reverse processes are balanced, and there is no net change in the concentrations of reactants and products. 4. While there is no macroscopic change, there is still molecular level activity as individual molecules continue to collide and exchange energy. Significance of delta G and equilibrium. 1. Delta G serves as a powerful criterion for predicting the direction of chemical reactions. 1. When delta G is negative, delta G less than 0, it indicates that the forward reaction is favored, and the system will naturally proceed in that direction. When delta G is positive, delta G greater than 0, the reverse reaction is favored, and external work is needed to drive the reaction. 2. Equilibrium, delta G equals 0, is a state of balance where the system has reached its most stable configuration under the given conditions. It is a fundamental concept in chemistry and thermodynamics, as it describes the point at which no further change occurs unless the system's conditions are altered. In summary, Gibbs free energy, delta G, is a key thermodynamic parameter that helps us determine whether a process is spontaneous, non-spontaneous, or at equilibrium. It provides critical insights into the energetics of chemical reactions and phase transitions, guiding our understanding of how and why processes occur in the physical and chemical world. If you like our video, kindly subscribe our channel, Mind Mentor, and hit the bell icon. Thank you for watching.